We start by choosing a pivot, usually the last element of the array. Here it's 2. We also use pointer I, initially set to -1, to track where smaller elements should be placed. First, we check 9, and since 9 is greater than 2, it stays in place, and I remains -1. Next, we check 3, which is also greater than 2, so no changes. Then we check 7, again greater than 2, so nothing moves. When we check 1, it's smaller than 2, so we increment I to 0, and swap 1 with the element at index I, which is 9. Finally, we check 6, no changes. After checking all elements, we place the pivot 2 in its correct position by swapping it with the element at I plus 1, which is 3. The final array has smaller numbers on the left and larger ones on the right of the pivot. Next, we repeat this process for the left and right sections of the pivot. The left section contains only one element, so it's already sorted. We now move to the right section and choose the last element, 3, as the pivot. First, we check 7, which is greater than 3. Since it's larger, no changes are made, and I remains 1. Next, we check 9, which is also greater than 3. Again, no changes are made. Then we check 6, which is greater than 3. Similarly, no action is needed. After checking all elements, we place the pivot 3 in its correct position by swapping it with the element at I plus 1, which is 7. We move to the right section 9, 6, 7 and pick the last element 7 as the pivot. Since there are no elements in the left section of 3, we skip directly to sorting the right section. First, we check 9, which is greater than 7. Since it's larger, no changes are made. Next, we check 6, which is smaller than 7. Here, we increment I to 3 and swap 6 with the element at index I, which is 9. Finally, we place the pivot 7 in its correct position by swapping it with the element at I plus 1, which is 9. And just like that, all sections are sorted efficiently. Happy coding!